Hey Codosaurs, my name is Dr. J and welcome back to this week's episode. Today we're going to learn about arrays, the simplest way of grouping information together. We're then going to work out how to work our way through each item in these arrays or in these collections so that we can produce some substantially more interesting diagrams. We're really starting to get those programming skills warmed up, so stay tuned. So up to now, we have learned two different ways of creating constants inside our programs. The first is simply to store a string into a constant like that, or another might be to create a mathematical expression like that. Well, today we're going to learn about a third way of creating a constant, and that is the array. As I said before, an array is a way of collecting together items of the same type, so maybe items of all strings or items of all numbers, but to collect them all together inside a single constant. And it looks like this. So an array is just a collection of simpler pieces of information. In this instance, I want to group three names together and store it in one constant called names. And in this instance here, maybe it's the number of times it's rained in the last 5 days, in milliliters maybe, and I want to store the 5 daily rainfalls in a constant called rainfalls. As you can see, an array is expressed in our language as by simply including the elements of the array inside square brackets. There's an opening square bracket and closing square bracket, either there or there, and then simply putting a comma between each of the items that we want to store in our array. So why might it be useful to do this? Why are arrays going to be useful for our programming adventures? Well, the simplest reason is it might just be easier for us to group a whole lot of information together and call them by a single name and then be able to pass them round by that single name. So remember, we could pass things to functions as a parameter. Maybe you want to pass a whole set of things to your functions in one go. An array allows you to collect a whole lot of things together and pass them around as one collection. Another reason is that most programming languages provide a mechanism to go through each item in the array. Normally these are called elements. So to go through each element in an array and run the same piece of code on each of those elements. This is called iterating through the array. So you iterate through each of the elements in the array. But before I start showing you about arrays, remember that write and step function that we created last week so we could actually see what was going on inside our dinosaur's head? I'm going to just quickly add that to our program now. So there we have our write and step, and we're going to be able to use that to now have a look inside these arrays and start using them. Okay, so what can we do with these arrays? Well, the first thing we can do is access each element, that is each item in the array, one by one, just by referring to its position in the array. And you put that position number inside square brackets. It looks like the following. There's our write and step function. Let's use our names array. And I want to have a look at what's sitting in position 0 in our names array. And you'll see there Lucy is printed out on the screen, and Lucy was indeed the first item in our array. An important thing to remember is most programming languages refer to the first item as being at position 0. Not like you might have thought that the first item should be at position 1. It's actually at position 0. The reason for this is an interesting one, and we'll cover it in a future episode, but think of it more like asking how far from the front of the array do you want to go to look for an array. So if you want to go 0 away from the front, well, you're going to be at the front of the array, and that's Lucy is currently in the front of the names array. So how do you think we're going to print out what's at the third position in this array? We want to get the Nora out. Well, we know it starts at 0, then 1, and then 2. So to get Nora out of this array, we're going to print out at position 2, and there we see Nora has been printed to the screen. So that's pretty straightforward, right? We've created an array, we called it names, and shoved inside that array we've put these 3 names, and if we want to access each of them one by one, well, we just put in square brackets after the names the index that we want to refer to, remembering that the first item is always at index 0. So what happens if we try access an element that's further than the end of the array? What if we try print out position names 20? I'm going to run this program, and you'll see in our programming environment here, it's just going to return a blank. Now don't be fooled. In most programming languages, if you try reach further into an array than there are elements in the array, your program's going to end pretty badly. Some pretty bad things will happen. It'll probably just stop running and exit out. So you don't generally want to be trying to reach further than the number of elements in the array. So, well, that you might then ask, well, how do I know how many items are in my array? And well, in our particular language, all you do is instead of accessing by the index in square brackets, you just put the word full stop length on the end of it, and you'll see it's printed out 3. That's the correct answer, that there are 3 names in this array. And if I add another one, so now we have 4 names in our array. If I run the program by pressing Control full stop, you'll see the length has now changed to 4. So up to now, we know how to access each item in the array by using the index operation inside square brackets, and we know how to find out the total length of the array just by sticking the word .length on the end of our array. But now it's all fine and dandy being able to access each item one at a time, but the real fun starts when we want to write one piece of code that operates on every item in our array at one go. This is where it's going to start getting interesting. So the easiest way to act on all the elements in an array at once is to use a programming concept called a loop. A loop is simply a computer science term for repeating a few lines of code over and over again. I guess it's called a loop because it's much like going round and round on a loop-de-loop. The code keeps going round and round over the same piece of code, working that code on each item of the array. So I'm going to create a new array here so we can have some fun with it. I'm going to call it colors, and I'm going to assign to it just 3 colors: red, green, and blue. Now without loops, how would I print out all the elements in this array? Well, it's going to be pretty boring code. It's going to look like this. Let me copy that line. We're going to have to copy and paste 3 times, printing out colors at position 0, position 1, and position 2. And when I run that, there you can see the red, green, and blue. But surely by now you know how much I hate duplicating code. Look how much of this code is pretty much identical. There it's right in step 3 times. There it's the colors 3 times. And all that's changing is the single number inside the square brackets. Surely we can do better than that. And you know we can. So I'm going to introduce you to our first type of loop in computer science, and that's called the for loop. And the for loop looks like follows. I'm just going to put in 3 dashes here so you can see the difference between where we were printing them out one at a time and where we're using our for loop to print them out. So you can see these ones here, red, green, blue, were printed out when we did it manually. I then drew the 3 dashes here. And now our for loop is printing out these red, green, and blue. And isn't it interesting, just with a single line of code there, well actually it's 3 lines for now, so you might think we haven't achieved very much. It was 3 lines over here, and now it's 3 lines here. But imagine there were thousands of items in this array. We would have had to have thousands of lines here, but this one would keep working. It'll remain 3 lines to print out all 1,000 items in the array. A for loop is called a for loop because of the way you read it out loud in English. If you look at this construct here, it starts with the word for, there is our array called colors, and it's saying for each thing of our colors array, I want you to do the following thing that's in the curly brackets. So for each color of the colors array, we're going to do the following thing inside the curly brackets. And you'll remember these curly brackets are very reminiscent of the curly brackets that we have inside a function, where we know that everything between these curly brackets will run when we call the function. Similarly, anything that we run, or any code that we put between these curly brackets here, is going to run for each color inside this loop. So in our case, our colors array has red, green, and blue in it. And so for each of those, it's going to come around, set this color constant, first to be red, then to be green, and then to be blue. And it's going to execute this write and step inside. So look what happens if I add a few more colors to our array. We've got our red, green, blue. Let me add yellow. Oops. Got our yellow. And maybe pink, and I run it again, and you see I only changed the elements in the colors array here. I didn't have to go change this piece of code down here, but this piece of code spat out yellow and pink as well. So you can see now, no matter how many colors we have in our array, this piece of the code here is going to write them all out. Whereas this piece of code here, where we copied and pasted the 3 lines, well, it's still incorrectly now just printing out the red, green, and blue. It's not printing them all out. So we've learned one thing. Arrays make our code much easier to read. We didn't need to be copying and pasting these, but now we know for each of the colors in the array, we can do multiple things at once. So how about we change the color to the actual color that's inside this variable every time. So when I run it now, have a look at our output. It's actually changing the color to the color we specified, because we know each item in this colors array is the word red, green, blue. So we know each time we come around this loop here through these lines of code, this color constant is going to be set first time to red. So it'll set the color to red, and then it's going to write the word red. Then it's going to go around this array again to the next one, which is green. It's going to set this color to green, and it's going to write out the word green, and so on and so on. And it's going to go through every item inside that array. And maybe to have a little more fun, how about we drop a little ball every time we come around this array, and then write out the name of the color. And here you can see when I run the code, there's a ball with the name red, a green ball with the name green. So you can see how powerful this is now. I'm only writing a single line of code here, but for each item in this array, it's going to spit out, or it's going to draw a much more elaborate piece of diagram. And maybe to have even more fun, how about we just turn a little bit to the right before we change color, draw our ball, and go forward. Now you can see we're starting to get creative. Before we drew our red one, we turned right 20 degrees. Then we turned right again, drew our green one. Turned right again, drew our blue one. So you can see, just by adding simple items to our array, let me add another one, maybe some white and some brown. Run it again, you can see we're starting to get pretty creative with what we can do, and our code is actually not that long. Okay. So up to now, we have just processed each element of our array using our for of loop. So we made this simple little archway with the balls and the name of the color, and they were drawn in the color. But what other cool things can we do now that we know how to go through a loop? So I wonder if you remember back when we were learning about the intermediate commands, and we had that little protractor underneath our dinosaur that showed us the angles, and we learned how to make various geometric shapes. We learned how to make a triangle, we learned how to make a square, we learned how to make hexagons and octagons. And if you remember, we learned there were 360 degrees in a circle. And if we wanted to create a shape with 6 sides, well then every time we wanted to turn, we had to divide 360 by 6, which would give us 60 degrees. We had to turn 60 degrees each of the 6 times we wanted to turn. And after 6 turns, we would have turned full circle all the way around 360 degrees and arrived back where we started. So now we know the amount you have to turn each time for a shape that, say, has 8 sides, you're going to divide 360 by 8, and that'll tell you how much you have to turn each time. So let me give you a little programming assignment. I'd like you to draw a shape that has the same number of sides as the number of items in our array. So if there are only 3 colors in the array, it's going to draw a 3-sided figure or a triangle. If there are 5 items in the array, it's going to draw a 5-sided shape called a pentagon. But the most important thing is, it has to draw that shape no matter how many items are in the array. You mustn't change the code each time you want a different number of sides. You just have to add or remove items from that array. So to give you some hints, the first thing you're going to need to remember is that .length command, which will tell you how many colors are in the array. You're then going to have to write an expression that will divide 360 by the number of sides, so you'll know how much to turn every time you make a step. And finally, you're going to put the pen down and make a for loop that inside that for loop, it's going to go forward a little bit and then turn right by the correct number of degrees. So go on, give it a go. It's a pretty tough challenge, but pause this video, give it a go, and then I'll show you the program once you're done. Okay, so how did that go? Here's my version. Let's see how close you got to it. The first thing I'm going to do is put the pen down. And also I'm going to just turn right another 20 degrees just so that our dinosaur will be facing down. So there you can see it's facing straight down. And then I'm going to type in the actual program. And look at that. We have 8 colors in our array, and we now have an 8-sided figure where it's a perfect octagon. If I change the number of colors in the array, where is that colors? If I say take out the red one, or maybe take out the red and green one just temporarily, and I run it, you see it's only a 6-sided figure now. If I put that red and green back, it's back to an 8-sided figure. And maybe to make it even more fun, let's make it slightly bigger. So I'm going to go forward maybe 40, and I'm going to make each side be the color of the color that we're currently processing in that array. So let's quickly go through my program step by step so you know what's going on. So as I said, the first thing I did was put the pen down, because remember we picked the pen up right at the beginning of our program, because when we were drawing this part we didn't want to be leaving lines behind us. But now that we're going to be drawing lines as our dinosaur moves, we need to put the pen down again. And then I just turned right 20 just so that he turned a little more to continue this arch. So then the real program starts here. The first thing I did, just so that it's much easier to read the code, is I created a new constant called number of sides. That's going to be the number of sides our shape has. And the number of sides is going to be set equal to the same length as our colors array. So if there are only 3 items in our colors array, number of sides is going to be 3. And we're going to get a triangle. If there are 20 items in our colors array, number of sides is going to be 20. The next thing I did, remembering that we had to divide 360 degrees by the number of sides, so the angle to turn each time is going to be 360 divided by the number of sides. Then we started the for loop, which we know is going to go through each color inside the colors array. So if we have 5 colors in the array, we're going to go through this loop 5 times. And then simply each time we go through the loop, I'm going to change the color of the pen to be the current color that we're going through the loop. I'm then going to go forward that 40 centimeters, and I'm going to turn left. So remember, the dinosaur is facing down, so turning left makes it look like it's our right because he's facing the other way. It's going to turn left the correct number of angles, and we worked out that number of angles over here when we made this constant. And so if there were 8 colors in this array, well, we know it's going to turn left 360 divided by 8, which is equal to 45 degrees. So it's going to go forward 40, turn left 45, and do that 8 times, and you're going to end up with this 8-sided figure. So don't you find loops to be pretty powerful? You're not going to have to change this program at all, and it's going to correctly not only create this arch over here, but then draw a number of sided figure that has the same number of signs as you put colors in that array. So go on, use your imagination. What other kinds of things can you come up with loops? And when you've done some of them, show your friends and your teacher what you've done. And well, that's all we have time for in this episode. The code for this lesson is going to be down in the description of this video, so if you need it, it's down there. And with that, this is Dr. J signing out. Until next time, ciao.